All right. So let's first talk about domain, because we're going to see this a lot throughout the semester, and it's important for everyone to know exactly how to find the domain. So when you're finding the domain, really what you're doing is you're getting rid of things that you don't want or things that are going to be quote unquote bad for the function. Okay, so to find the domain of any function, you really want to think about the things in math that we cannot do. Okay, and I'm sure you guys know most of these, and we're actually going to add to this list as the semester goes on. But here's some mathematically invalid operations. One, and this is going to be the same for any class you take in math, you can never divide by 0. Okay? So if you ever have an x value that would lead to you dividing by 0, you want to throw it out. 2, you cannot take the square root of a negative number. So if any input would lead you to taking a square root of a negative number, then you want to throw that out as well. Okay? Let me go ahead and annotate these. So again, we cannot divide by 0. So if we have something like this, that's bad. We can't have square roots of negative numbers. Okay. Now again, we will add to this as we progress through the semester, but at least initially, these are the 2 golden rules of math that we want to obey. Okay. We cannot divide by 0, and we cannot take the square root of a negative number. So if you're trying to find the domain of a function, what you really want to do is you want to think of, are there any inputs that would lead to these mathematically invalid operations? And if there are any, you throw them out. And whatever's left over, that's what we would call our domain. Okay. Let's look at some examples. So number 1, f of x is equal to 3x squared minus 5x plus 2. Okay. Now, hopefully you guys recognize this. This is what we call a quadratic function. We're going to get some more experience with these next week. So let's find the domain of this function. Okay, so again, we want to keep in mind our golden rules. We cannot divide by 0, and we cannot take the square root of a negative number. So if we analyze our function here, are we ever dividing by anything? No, just 3x squared minus 5x plus 2. And are there any square roots? No. So there's no inputs that would lead to us having a quote unquote invalid mathematical operation here. So our domain in this case would just be negative infinity to infinity. Okay, and again, that's because there's no dividing and no square roots. So this is almost like the perfect case scenario. This is a very, very nice function in terms of domain. Okay. Now remember this interval notation here, negative infinity to infinity, that means the whole entire real line. We're not getting rid of anything. All right, let's look at number 2. G of x is equal to 1 over x plus 5 times x minus 3. Okay. Now, again, if we're finding the domain, keep in mind your 2 golden rules. You cannot divide by 0, and you cannot take the square root of a negative number. So again, when we analyze our function, do we have any square roots? No. Okay, we don't have any of these things floating around. But notice we are dividing. Okay, we're dividing by an x plus 5 times an x minus 3. So then you want to ask yourselves, okay, what would make that 0? Okay, and remember, we're going to be using our 0 product property. If you have 2 numbers that multiply to 0, and we'll see this a lot throughout the semester, this means that one of them has to be 0. Okay, so when we're going to see when this denominator here is 0, what we're going to do is we're just going to take each piece and set it equal to 0. Okay, and what do we get in each case? We'll get here, x is equal to minus 5. So if we plugged in x is equal to minus 5, that would make this portion of the denominator 0, which would lead us to dividing by 0. Okay, so that's a bad value. For this x minus 3 part, we would get x is equal to 3. And that would make the other part of the denominator 0. Okay, so again, these are our bad values here. If we plug in minus 5 and 3 into this function, we're going to be dividing by 0, which we don't want to do. So our domain would be everything but those 2 values. Okay, so I'm going to draw a number line so we can visualize this. So here's minus 5 and 3, and we're going to get rid of these. And the way I'm going to denote getting rid of them, I'm just going to put holes here. Okay. But everything else is okay. Everything else is fine since we wouldn't be dividing by 0, and we're not plugging negatives into square roots because this function has no square roots. So our domain would be everything but negative 5 and 3. Now, how do we write this in interval notation? So this part of our real line, this would be negative infinity all the way up to negative 5. And notice I'm using an open bracket because I don't want to include negative 5. Remember, that's our bad number. And now I'm going to put a U here for union. This means and, well, or sometimes, but in any case. Negative 5 to 3, which is this chunk here. Union, this chunk right here, that's 3 all the way to positive infinity. So this would be the domain of this, what we're going to later call rational function. Let's look at another example. H of x is equal to the square root of 1 minus 2x. Okay, so let's find the domain of this function. Now again, when you're finding the domain, think about your 2 golden rules. You cannot divide by 0, and you cannot take the square root of a negative number. Okay? Now in this case, if we analyze our function, notice we have a square root. We don't have any dividing going on, but we do have a square root, so that we have to be very, very careful. Okay, now remember, you can't take the square root of a negative number, so what we're going to do is we're going to take the inside here, and we want to make sure that that's always non-negative, okay? We don't want that to be negative, otherwise we blow up the universe. So what do? We're going to take that inside, and how do you make sure that it's not negative? Well, you set it greater than or equal to 0. Okay, this makes sure that the inside stays positive. Well, it stays non-negative. Inside stays non-negative. Okay. And now we just solve for x. So I'm going to go ahead and add 2x to both sides, divide both sides by 2. So our domain would be all numbers, okay, that are less than or equal to 1/2 here. Okay, so let's draw the number line. I'm going to put 1/2 here. Okay, and now notice 1/2 is greater than or equal to x. That means we're coloring in the left side here. So things like 0, -1, -2, and so on and so forth. And notice we have this greater than or equal to sign here. So that means that I'm going to put a filled in hole here, not a hole like we had in the other example. So what's our domain in this case? Our domain would be, okay, again, reading from left to right, negative infinity to, and remember, since we're including that, I'm going to use a hard bracket. Okay. And that's finding the domain of a function. So remember, if you're trying to find the domain of a function, first step, analyze the function. What do you have going on there? If you're dividing by something, make sure that that something is never 0. If you have square roots, make sure that the thing underneath the square root is never negative. Okay? And if any x values lead to you breaking one of those rules, you throw it out. And whatever's left over, that's what we call the domain. Now for range, the best way to find range at this point in the class is to really just graph the function and look at all the y values. So let me go ahead and share Desmos. And I have some examples I want you all to look at. So our first example here is f of x is equal to 2x plus 1, which if you look at the screen, that's just a line, okay? Now, what is the range of this? Notice that, and think about lines, the lines are going to keep going up this way, or this line in particular keeps going up this way and keeps going down this way. And so if we look at all the y values here, okay, so look at the y-axis, notice that this function is hitting every single y value here. You can think about it as drawing horizontal lines too, which is kind of hard in Desmos, but in any case, notice that our function is hitting every single y value here. So our range in this case would be negative infinity. Ooh, not integrals. There we go, to infinity. Let's look at another example. So here's g of x is equal to the square root of x minus 2. Okay, let me move over a little bit so you can see it better. Now, what's the range of this function? So notice here, again, look at the y values. What are we getting? So we're getting 0. And notice, what does the function do? It just keeps getting bigger and bigger and bigger and bigger this way. Okay, so our range would be 0 all the way up to infinity in this case. And if I zoom out, notice it is increasing. It just keeps increasing and increasing and increasing and increasing. So our range in this case, again, looking at the y values here, draw your horizontal lines here. And you would get, in this case, 0. And notice I'm using a closed bracket there because we do actually get the value 0 here. Look at that y coordinate. All the way to infinity. Now remember, with infinities, I do not want to add a hard bracket there because infinity is not a number. Okay, so our range would be 0 to infinity. And our last example for the day, 1 over x minus 3. Okay. So let me go ahead and move this over a little bit so you can see. So again, we're looking at the y values. Now, one thing that I want you to notice for 1 over x minus 3, okay, it looks like we're getting almost all y values here, but I want you to look at the origin there. Okay, it's 0. Does this graph actually touch the x-axis? And the answer to that is no. If we zoom in, it looks like it's getting close, but it never actually hits the x-axis, which means that we're never getting a y value of 0. Let me show you just so that you see it's not a fluke. Let's look at the other branch. And notice again, this function's never actually hitting the y-axis. I'm sorry, the x-axis, meaning again that we're not getting an output of 0 for this function. Zoom out a little bit, go back to this. So what would our range be in this case? It would be everything except for the number 0. So how do we write that? So minus infinity to infinity. And again, notice I'm using the open brackets there. All right, and that is it for